Welcome to the Agent Effect podcast. I'm your host, Paul Jarrett, and I'm delighted to be joined by two of the brightest minds in the AI industry, Adam Cheyer and Babak Hodjat. Adam is the co-founder of Siri and Bixby, which were later sold to Apple and Samsung, respectively, and is the VP of AI Experience at Airbnb. Welcome, Adam.
Thank you.
I'm also joined here by Babak Hodjat, the CTO of AI at Cognizant and the inventor of the natural language that evolved into Siri. Welcome, Babak.
Thank you very much.
So let's start. I mean, there's a natural connection here between both of you around Siri. Can you perhaps explain that? Like, how did you come to meet each other and work with each other?
Yeah, I was challenged by a friend that didn't know better to start a company around using actually agents to do natural language. And the first person I looked up was Adam. I was in Japan at the time, and I'd read Adam's work. I didn't know Adam. I cold emailed him, and he was just awesome. And he responded. He's like, "Yeah, let's meet." So we actually flew out to the Valley. I met Adam at SRI. He spent like 2, 3 hours with me, showed me the demos, walked me through Agent Architecture (OAA) and how he had used it in his systems. I walked him through some of my ideas around kind of like a distributed version of OAA, which ended up being AAOSA. And Adams really encouraged me. He's like, "Yeah, that looks like you're on the right track." I mean, and the rest is kind of history. That was my first meeting, and very, very inspired by Adam.
Yeah, at the time, this was in the mid 90s roughly, and there were not a lot of people who worked on three different things: user interfaces, distributed technology, and artificial intelligence. So if you really did an intersect on people who did all three,
Mhm.
you pretty much came down to me and how I felt at that time. So we hit it off, and it's really had slightly different approaches, slightly different points of emphasis, but the spirit and the synergy between those three aspects, I think, has been a hallmark of our both of our work and careers.
Fantastic. So, Adam, can you tell us a little bit about your backstory, behind evolving that into Siri and how that came to be?
Sure. So in the early 90s, I had this open agent architecture system. So the idea was to be able to delegate work to agents. Again, at the time, if you think of objects, there were systems like Corba and distributed object systems. People would build components and then lash them together, or in enterprises, sometimes use workflows to bind them together in very rigid ways. And I was always very, very interested in how could you have communities of agents as opposed to just static objects that could interact and compete and cooperate. And when a user made a request of a task, either through language or through graphical interfaces or combinations of both, the agents would self-assemble and attack the task. So that's what I was doing in the 90s. I spent a number of years and built maybe 50 different prototypes and versions, all based on the same architecture and approach, but for many, many different domains. After that, I went to the enterprise world. I was VP engineering of one of the top 5 IPOs of 1999. It's called VerticalNet, all about supply chain and auctions and things of that. We shipped a lot of code, but there was still this notion of how do you have more flexible, delegated computing. And then in the 2000, after leaving that company, I, was an advisor for Babak's natural language agent focused company called Dejima. And I got so excited when they hit on some application ideas for how to apply it, the technology and platform they developed. We discussed, and I ended up joining as VP engineering. And that was the first time we formally worked together. And we did that for a few years. I then left and joined SRI International, used to be called Stanford Research Institute. I ran technology for the largest government-funded AI project in history. It was $250 million over about 5 years. It
Wow.
was called PAL, and our instance of it was called Kalo. And the idea was to build an agent or an assistant that could learn in the wild. So it would watch the user, build profiles of them and of their work life. Who do they work with? On what teams? What are their projects? What are the roles of different people? And then it would help with applications in those areas. And I got to bring in some of the best minds in the country. We had 27 or 28 universities, everyone you can imagine, MIT, Stanford, Carnegie Mellon, University of Washington. But of course, we also needed Babak's mind on the project. So we had one or two commercial companies on this advanced research project. And Babak and team were part of that effort. And after several years on this government-funded project, I got the startup bug. I had seen Babak be successful doing probably two startups at that time. And so I decided to do three.
We're
One
very
of
competitive,
Yeah, I
just
can
so
see.
you
I
know.
exactly.
can see.
So I started Siri as a company to really commercialize a lot of this technology for mobile assistant use case. Babak and I teamed up on a company called Sentient, working on looking at machine learning at scale. And then I also was first developer and founding member of change.org, the world's largest petition platform, more than 500 million members today.
Wow.
So that's the
You
start.
know, when I think about it, some of the work we did, a lot of it under Adam's, innovative thinking, even back during Kalo. I remember we built this system for setting up meetings, and it was a multi-agentic system, and it was seamless. Like you would call. Back then we had like landlines. You could call or send email or so forth and say, I want to meet with these people, and it would automatically reach out to the people or call them even and find out the common times, set it on the calendars. We're talking early 2000s here.
It's amazing.
And then on the day, you would walk into the conference room and it would dial everybody out and the meeting would happen. Like it
Wow.
was as seamless to this day. I want to do a Zoom call or something, and it's like a headache, and you can't find what to click and where to go. And I think, oh my God, I wish we had that. And I think that's the theme, right, Adam? The theme is you come up with these really amazing technologies, even when I look back at OAA or AOSA and those things, and they're so much more functional than their actual incarnation in the real world today. They're so much more limited. I wonder why. Like, have you ever thought why, they get so like, I don't know, clipped. The wings get clipped off the technologies.
In many ways, when I look back, all of the systems, I can tell the story how, as we go further back, and I actually did a presentation called Siri Back to the Future, where
Oh,
I
cool.
said, here is the
That's the
app
theme.
that, was so amazing that we launched as a little startup that 2 weeks later, Steve Jobs called our office unannounced and said, hey, come over to my house tomorrow,
Wow.
and wanted to buy the company. And it was incredible. But if you want to know what was better than that, go backwards 3 years. The version we had brought to VCs, it had all this functionality. You could drag and drop and do these amazing things that you couldn't do in the version we commercialized. Oh, but and so I told the story going back some 30 years, and every time you go backwards, something gets better and improved and never made it in. It was left on the cutting room floor, never got into the production version. But also tell the story the other direction, because many of those early systems were just prototypes. They didn't scale. They had, they had their flaws. And so when you go in the other direction, you can also say, well, look, yeah, but it got better and better. The Siri we launched on Apple maybe wasn't as functional as the ones we had earlier, but it was on 2 billion devices. That's pretty cool. Right.
Very
So,
cool.
I think we can be nostalgic. We can look at all those cool things that we built along the way and that never made it into production. And boy, we had it good then. But I also see the value of the things that did get into production and did impact the world and change the world. And so even if it wasn't the full vision we imagined, sometimes getting something more narrow, but really having impact and value, that's worthwhile too.
I agree. And I think by the same token, sometimes you look back and you're inspired by some of that early ambitious thinking that is now eventually,
Hmm.
can be made possible. Like, some of the multi-agentic technologies that we thought of back then. I think it was overambitious back then. I think agents of that time required a lot of engineering, a lot of work. And maybe today, some of what we aspired to do back then is now possible after 30 years.
Yeah, I don't think it was overambitious to be thinking and dreaming about
No,
it.
not
But yeah,
to actually
build it, yeah, well, maybe. Maybe.
Let's talk about a little bit about today. I mean, there's a lot of people talking about agents. They're kind of making this resurgence. And there's a lot of different definitions of what an agent actually is. So I'd love to hear from you, like how you both think about describing what an agent is.
So it changes a little bit over time, but not that much. In the 90s, the competition to an agent was an object, as I mentioned. Components that encapsulated certain amount of functionality. It could do some things. You could query an object, but you had to call these hardwired APIs, right? Interfaces to be able to get it to do the functionality. And the way that those objects were invoked was very static, prescribed in advance. So for me, I always have seen agents as, yes, it is a bunch of functionality.
Mhm.
It has capabilities and can do things. But what's more than just an object? An agent should be able to communicate, cooperate, delegate to other agents, right? That's an object doesn't delegate, it doesn't communicate to others. And you should be able to ideally assemble a community of these things
Mhm.
and have them, much more if we got a bunch of experts together, it wouldn't be exactly prescribed about how the communications flow and exactly how it works. We're
Mhm.
going to figure it out, right? So
Right.
having some agency to be able to adapt and live and communicate and reflect and contribute and delegate. For me, those are very much the properties of agents. The last thing that I would mention today, the word agentic gets thrown around a lot.
Mhm.
Um, there's a notion of independence and autonomy that often is associated with today's agentic systems.
Okay.
So in the first place, it's really about communicating and flex and cooperating with other domains or components,
Mhm.
but maybe they're assembled for an application in some form. Agentic can survive. It's almost like a long living agent that independently and autonomously has some goals that it tries to achieve. So I might set up an agent to be monitoring a certain aspect of my business. And if certain things happen, to be able on its own figure out what are the appropriate responses to handle that, for instance. So that's not a definition in respect to other multiple agents.
Right.
It's more of the way that a system behaves in a long life, uh, autonomous um, fashion where it is making decisions based on what the stimulus of the outside world. So,
Interesting.
Yeah,
Babak,
I
do
mean,
you?
I love that definition actually being inclusive of the fact that your agent is in like this community of agents, or it's defined as being able to delegate to other agents. I love that. Even back in the 90s, there was this duality. Like you had these very large agents, and they were thought of as being single agents that you delegated a task and they would go off and do something on the internet and come back to you. But what I really liked about especially Adam's work back then was that he wasn't thinking about a single agent. And in fact, I really like, including multiple agents as being the definition of an agent. You know, I can't beat the definition that Adam gave, but just to give you like a different perspective as to the modern day agents, um, they seem to require you to have a large language model
Hmm.
as its reasoning and natural language capability and some code. So it's those two put together, so that you have basically you're extending a model that only takes input and produces output to now be able to actually make calls and like actually affect the outside world. So at its minimal, that's the definition of an agent. But then as soon as you create one agent, you want that agent to be able to talk to other agents, to delegate, those other agents that are responsible for some other set of tools,
Hmm.
for example. And so multi-agency is just so natural and organic that I think it's part and parcel of what we think about when we think agents. Um, Last thing I'm going to say here is um, it's really helpful to think of our modern day agents as that combination of a black box, pre-trained large language model with some capabilities out of the box,
Hmm.
that is not consistent. Typically, you ask it a question twice and it'll give you two different responses, paired with code. What does that imply? That implies that you have full authority over that code. You're writing that code. You know exactly what it's going to do, and it's repeatable, and it's going to do it every single time. And so I think that's very useful when you design and build these agentic systems to say, okay, where do I draw the line? Where's the delineation? Where do I need to actually defer, for example, on the autonomy question, to the large language model to decide which tool to call, when to call it, or how to call a different agent, or how to interpret what I'm saying? And where in the job description of this agent do I really need consistency? And there's some rules that need to be followed and some safeguards to be there. I think when we start thinking that way, it takes away some of the inhibition that we
Hmm.
see out there in utilizing these systems and saying, oh, they hallucinate. Oh, what about error propagation? Those sorts of things, because, built into the concept of the modern agent, you do have that option of where you delegate the responsibility. So just bringing that perspective.
So you talked a lot about LLMs and their progression over time. What other like influences have there been over the last few years to bring this resurgence of agents to the forefront? Like, what have there been other technology breakthroughs? What have been the kind of the new pieces of or the new innovations in the last few years that have really made agents come back?
Well, of course, generative AI and
Yeah.
large language models. And I think we were on this track, many thought of, general intelligence. And in some ways, large language models are generally intelligent. You can ask them anything and they'll try to answer.
Hmm.
Um, the moment you actually want to use them in practical
Hmm.
applications, you have to give them a job description. You have to tell them, like prompt engineering is all about telling your large language model, here's what I expect from you to do, and here's how I want you to do it, and here's how even I want you to format the response to me.
Yeah.
So the moment you start thinking that way, you're kind of restricting, you're kind of putting this very powerful model in a box and saying, here's your job description, and here are some tools that you can use. And I think that just necessitates thinking agents. Like that's the mindset has to be, to Adam's point, that module,
Hmm.
basically that object that now has some level of autonomy and some, because of large language models that can understand natural language as well.
Yeah, I would just add on to that. So why are LLMs so important? What do we use them for? One is they're great at language understanding. So that's
Mhm.
something that in the early days we did not
Yeah,
have
very
as a
tough.
tool. And, when Siri came out, people are like, why is it hard to understand language? Why doesn't Siri always understand everything perfectly? There's a lot of ambiguities that happen. I used to give the example, if I say book a four-star restaurant in Boston, you know immediately what I mean.
Hmm.
But if you think about it, which city am I talking about? Boston. There are 13 Bostons in the United States. And did you know that Star is a city in the United States and Book is a city in the United States? So which city am I talking about? And Star
Yeah.
Restaurant is the name of a restaurant. But I'm not talking about a restaurant name. I said four-star restaurant. There are so many combinatorial possible interpretations. That's pretty much been solved with LLMs, and it's a relatively new tool. So language understanding is important.
Hmm.
Language generation is important. We used to have to script
Yeah.
responses. Like you could speak flexibly, understand something, we could do something, but then it had to speak back to the user, and we would write these hardwired scripts. Don't need to do that anymore. The LLM can figure that out. And the third and sometimes underlooked aspect is the reasoning capabilities.
Hmm.
So Siri solved many of the language understanding aspects, not completely, but pretty well enough to deploy at scale for millions of words and handling the ambiguities and all of that. But then the actions were hardwired. I would add as a breakthrough LLM's ability to code, to
Okay.
actually write code was stunning to me and probably the biggest surprise that ever happened in my career. Because I'm like, yeah, I know the algorithms. I've been working with people on this. In an essence, it's a word predictor. It's very good at language generation, language
Hmm.
understanding. But to code, you need to understand what each line of code means. And it's not just regurgitating code. If you
Hmm.
say, I need you to change this program for me, it needs to know what each line does so that it could go and edit it and what the impact would be. And that I couldn't conceive of. When I saw that AI could had enough logic and understanding, not just the surface level of what words mean and how they go together, but it could understand code and operate on it. I'm like, that was shocking. I literally fell out of my seat. And then I realized these assistants are not just doing text and token manipulation. They have a model of the world of some level of understanding. It's not quite the same as humans, but it's able to reason, make predictions, to use what it knows about how everything works. So when you get into systems for enterprises and others, how do you string together these operations for some novel use case? Something new has happened. You need to have an understanding of the business. You need to have the ability to think and reason. What are the implications of what I just saw? And you need to be able to, I'll say, write code, string together operations that might resolve the problem that's come up. And that is breakthrough in the last 5 years and surprising to me,
Great.
literally shocking.
Yeah.
And just one thing to
Yeah.
add here is notice that when Adam is talking about large language models and the value that they have, he talks about natural language understanding, natural language generation, and reasoning, part of which is writing code. He's not talking about an oracle that will answer your questions.
Right.
And while it can do that because it's trained on a lot of data, that should not be the number one usage of these systems. And I think that's a major mistake that many make when it comes to large language models and AI,
Hmm.
is they think that, we can ask it any question and it should be able to tell us.
Right.
Well, it's pre-trained. For starters, its information is old. And then it has a concept, it has an abstraction of what the world looks like. It's not a knowledge retrieval system.
Hmm.
So I think that's not as significant, in my opinion, especially in using it in agents, as the other properties that Adam talked about.